So last part of 2.2, let's see how can we use the knowledge we have learned today, the property of equations and the graph of the equations, right? How to use those to graph key equations. So let's look at this example. Graphing the equation y equals negative x to the third power by finding intercepts, checking for symmetry, and plotting points. All right, let's find the intercepts first. This one easy find, right? We find the x-intercepts. We let the y coordinates be 0. So we got a 0 equals negative x to the third power. And then find the third roots, which is 0, right? Only x be 0, and then x to the third power times negative 1 can possibly be 0. So x-intercept is 0, 0. And then y-intercept, same way. We let x equals 0, right? And then y equals negative 0 to the third power is also equal to 0. So both x and y-intercept right at origin 0, 0. Now let's testing the symmetry property. Okay, I think the book explains very clear. So testing whether it's symmetric with respect to the x-axis, we replace y by negative y and then plug in to the equation. So left-hand side, y, right, replaced by negative y. Right-hand side, no y involved, so we just copy the original equation, which is negative x to the third power. So this new equation, okay, we cannot further simplify, or if you want to simplify both sides of the equation, multiply by negative 1, so you will get y equals x to the cube. Okay, if you do that, that's fine. So after simplify, we compare this new equation with original, right, which is not equivalent to original equation. You see the right-hand side missing the sign. That's why we say the graph of this equation is not symmetric with respect to the x-axis. Now let's check in the y-axis. We replace x by negative x. Okay, and then left-hand side no x, so we just copy y equals, and then right-hand side replace x by negative x. Okay, replace x by negative x. This negative sign is original problem's negative sign. Okay, and then negative x to the third power. Okay, third power is the odd number, so negative 1 raised to the third power is negative 1. So the negative 1 come out, okay, and cancel with outside negative sign. Negative, negative become a positive, right? So we simplify as y equals positive x to the third power. Okay, you compare this equation to the original, you will see right-hand side, the sign is different. So not equivalent to original equation. Therefore, the graph of this equation is not symmetric with respect to the y-axis. And then testing symmetric property with respect to the origin, we need to replace both x and y by its negative. Okay, and then plug into equation, let's see. So replace y by negative y, replace x by negative x, and simplify. So right-hand side, negative x to the third power, so we have a negative sign coming outside, and then cancel out with another negative sign outside, right? So we got a negative y equals positive x to the third power, and then both side equation multiplied by negative 1, we simplify as y equals negative x to the third power. So compare this equation to original, they're the same, right? Equivalent. That's why we say graph of this equation symmetric with respect to the origin. So no symmetric with respect to the x, no symmetric with respect to the y, but does have symmetry property over origin. So now we can graph this equation by plotting the points. So we create a data table, and then we just let x coordinates, okay, or variable x be 0, 1, 2, 3, okay? And then we plug in equation, evaluate y. When x equal to 0, 0 raised to the third power times -1 still 0, right? If x equals 1, 1 raised to the third power still 1, 1 times -1, that's -1. And then if x equals 2, 2 raised to the third power is 8. 8 times -1, that's -8. And then do the same thing if plug in x by 3. 3 to the third power, 27 times -1, 23. So we got 4 points here, and we already know the graph symmetric with respect to the origin, right? So that means we can, get the other 4 points, right? Which is both x and y must be the negative 0, 0, -1, +1, right? Based on symmetry property. Okay, 0, 0 is still the same. And then -1, +1, -2, +8, -3, +27 must be also on the graph, right? So we can graph half and then use symmetry property to get the other half. Okay, so we got this half of the graph, and then we can use symmetry property to get the other half. The graph symmetric with respect to the origin, 0, 0. Okay, that's one of the example. Let's try another one. Graphing the equation x equals y squared. Okay, we do the same thing. Find the x-intercept and then check for symmetry and then plotting the points. And we can also use the graphic calculator to graph that equation. Sorry. So let's find the intercept first, okay? Find the x-intercepts. Let y coordinates be 0. So x equal to 0 squared, which is also 0. Okay, so x-intercept is 0, 0. Find the y-intercept. We let the x coordinates be 0. Right, so 0 equals y squared. And then we solve y also equal to 0. So still 0, 0. So both x and y intercept is on origin 0, 0. And then test for the symmetry, okay, similar to x-axis, we replace y by -y. I just write a short, okay? So x equals -y raised to the second power, negative sign raised to the second power cancel out, so just x equals y squared. So you can see x equals y squared, that's exactly the same as original, right? Equation. Therefore, the graph symmetric with respect to the x-axis. And then testing y-axis, we replace x by its negative, and then we got a negative x equals y squared. So this already simplified. Compare with original, right? It's not the same, right? Left-hand side missing the sign, right-hand side is the same. So no symmetrical property with respect to the y-axis. And then the origin, just combine x and y. Replace x by negative x, replace y by negative y, and then we got a negative x equals, this is x, okay? Negative x equals negative y squared. Simplify, negative sign here cancel out. So that's negative x equals positive y squared. And then compare this with original, left-hand side missing the sign. That's why no symmetric with respect to the origin. All right. And then we pick up a few points. X and y. Choose x equals 0. we got y equal to 0, right? X equals 1, and then x equals y squared, so 1 squared is still 1, and then y equals x squared, I'm sorry. Right, x equals y squared, that's right. X equals y squared. So we got if y equals 2, 2 squared will be 4. Okay, if y equals 4, 4 squared 16. Okay, all right, and then we can plot. Or we can do 3 too. X equals 3, y equals 9. Okay, so we got this half of the graph, and then we know it's symmetric with respect to the x-axis, so we can do the mirror image about the x-axis, and then we got the other half of the graph. And this equation we can use graphic calculator to solve also. Okay, so we got x equals y squared, but we need to represent in terms of y. We need to solve for the y. Okay, so we interchange the signs. Y squared equals x, and then solving y equals plus or minus square root of x. Okay, so we can put the two function into the graphic calculator, like a y1 equals a positive square root of x, y2 equals negative square root of x. Okay, and then that's the graph you will see. This is a y1 square root of x. This is a y2 red color one. That's a negative square root of x. The last example, we try to use the property we learned to graph the key function y equals 1 over x. This is reciprocal function. So find the intercepts. We noticed variable x on denominator, so we know denominator can never be 0. Okay, therefore, we don't have x-intercept. If x can never be 0, so 1 over x y can never be 0 also. Okay, so we know for this particular function, there's no x-intercept, no y-intercept, or in other words, the graph will never either touch or cross the x and y axis. Okay, both axes never touch or cross. And then testing symmetry property, okay, same process. Testing for x-axis, we replace y by negative y. Okay, so we have negative y equals 1 over x. It's already simplified. Compare this original, not the same, so no symmetric with respect to the x. Let's check the y-axis, see if it have a symmetry property. Replace x by negative x, so y equals 1 over negative x. This is different than original equation, right? So not symmetrical with respect to the y either. The origin 0, 0, let's see. Both x and y replaced by its negative. So we got a negative y equals 1 over negative x. And then both sides of the equation multiply by negative 1. So negative sign cancel out. We got y equals 1 over x. This is equivalent, right? Equivalent as original equation. Therefore, graph of this equation symmetric with respect to the origin 0, 0. Okay, so this is the book. Go through the same process, checking symmetry property. And then we can graph this function by plotting the points. So we create a data table. Okay, choose x be those value, and then 1 over x. Okay, and then we plot. So that's the graph we can get. Okay, because this graph is very hard to, graph by hand. That's why I just, showed you how the book did it. And you can see the accurate graph. Those all goes to infinity. Okay, you will see this graph, this two curve is located in the first and third quadrant, but they never touch or cross across x-axis or y-axis. Okay, and the graph symmetric with respect to the origin 0, 0. So this is the last slide of 2.2. Okay, we done with section 2.2 today.